Today we're going to move into section 5.1, which is solving systems of linear equations in two variables. And some of y'all might have seen this before, and some of you maybe not, in two variables. But in any case, if you have seen it, this will be a good review. If you haven't seen it, don't worry, that's why we're covering it. I'll also say if you have seen this, don't blow this off, because next time we're going to talk about doing this in three variables. So if you're not comfortable doing this in two and you try to move to three, you're going to be in big trouble. So essentially, we're going to start off by looking at problems like this. Something like, say we've got x plus 2y equals 2, and x minus 2y equals 6. So the idea is eventually we are going to determine what x and y are that meet both of those requirements. But first of all, we're going to start off by testing if various things are solutions. So you'll have a homework problem that will say something like, verify for, or verify if, we'll say verify if for -1 is a solution. And that'll be a question by itself. Then there'll be another question that says verify if -4, 3 is a solution, or some other number. So whenever you're doing this, essentially what you're going to do is you're going to plug in the values for x and y, into each equation. If it satisfies the equation, if each one, if each one is satisfied. So like, if the first equation is satisfied and the second equation is satisfied. I just can't settle on something. Let's try this. If each equation is satisfied by that one point, so xy, then xy is a solution. Otherwise, it's not. So if it meets one but doesn't meet the other, it's not a solution. In order for this to be a solution to the system, each equation has to be satisfied. So both, must work. So both the solutions must work, or it's not going to be okay. So let's practice and see what we can do with this. All right, so I'm going to rewrite the point that I'm looking at. I'm going to be looking at the point, let's see, 4, -1. So this is the point I'm going to test. And so for a -1, that means that x is 4 and y is -1. So I'm going to test the first equation, and I'm going to test the second equation. So the first one is x plus 2y equals 2. I'm just writing this, so I have to scroll back later. X minus 2y equals 6. Okay, so I'm going to plug these values, and I've got 4 plus 2 times -1. And I want to say, is that equal to 2? So I'll say, all right, is 4 minus 2, is that equal to 2? Yes. So this one, that one works. That's good. Okay. Well, let's try the other one. If x is 4, minus 2 times y, which is -1, is that equal to 6? So say is 4 plus 2, is that equal to 6? Yes. Since it meets both requirements, 4, -1, is a solution to the system. So on your homework, these are going to be pretty much yes/no questions. Yes, it's a solution. No, it's not. So let's look at a different one. So the other point that we were going to investigate is -4, 3. All right. So we had -4, 3 is the other option that we're going to look at. So if that's the case, then x is equal to -4, y is equal to 3. All right. So x plus 2y is 2. We have to test both of them. Equals 6. So I've got x is -4 plus 2 times 3, is that equal to 2? Negative 4 plus 6, is that equal to 2? Yes, it is, so I'll go ahead and test the next one. Negative 4 minus 2 times 3, is that equal to 6? Is negative 4 minus 6, is that equal to 6? And we'll say no. So since it doesn't meet both requirements, that is not a solution. Because it has to meet both. So if it meets one but not the other, it doesn't matter. It's still not a solution. So how could we figure this out? Why is one of them a solution and one of them not? Are there other solutions that we need to look for? So let's figure out how we would kind of investigate that. So to really figure out what's going on here, we're going to graph these. Okay, so start off by graphing. If we want to graph these various things, we need to get them into what kind of form? What kind of form do we need to get these puppies in? I'm going to move this down. You should be at home saying, we need to get them in slope-intercept form, right? Slope-intercept form. That's what we're going for. Alright, so let's get this first guy into slope-intercept form. Means we need to get the y by itself. So we'll subtract our x and get 2y equals minus x equals 2. Alright, divide by 2. And I'll work this out once, but I really hope that you're getting good at this. I don't know why I did that in red. Negative 1/2 x plus 1. Alright, so I expect you to go from here to here in the future. And if you're having a hard time with it, just let me know and I can give you some additional advice on how to get that. But you really should be getting good at this. So in this case, my slope is negative 1/2, and my y-intercept is 1. Okay. So if I'm going to graph this puppy, I'm going to get, and this is going to be funny because I'm not going to get it straight. Alright, my first one, so I'm going to graph the first one in blue. I'll go to y-intercept is 1, and then my slope is negative 1/2, so down 1 over 2. Okay. So really it's going to look like that, something like that. Okay, so that's my first one. Now let's look at the second one. The second one is x minus 2y equals 6. X minus 2y equals 6. So, and I've got y equals 1/2 x minus 3. Again, if you're having a hard time getting there, don't just sit around and mope. Actually, ask me, but I do want you to be capable of getting there a lot faster. So my slope here is 1/2. My y-intercept is negative 3, right? So 1, 2, 3, 1 up over 2. And I'm going to draw this guy in like this. No, that wasn't quite right. I'm going to try a little bit better. I go like this, and this guy goes like that. So what do we have here? What do we call these lines? These lines are intersecting, right? We have intersecting lines. Now, where do they happen to intersect? What is this point right here where they intersect? It looks like it's at 4, negative 1. Now, what's 4, negative 1? 4, negative 1 is the solution to the system. So this here is the solution to the system. The solution is where they intersect, right? That's not accidental. That's very, very much on purpose. So what we have here is we have with intersecting lines, so this is kind of what I want you to get out of this. Intersecting lines means we have exactly one solution. If they're lines, they can only intersect, if they intersect once, they're going to intersect once. You know, this line can't come down and like intersect that again because that wouldn't be a line anymore. So if you have two lines that intersect, it means they have exactly one solution. And again, I really want you to get this, what we're talking about in 2D, because whenever we switch to 3D, we're not going to be able to draw them and graph them and say, oh, look, this makes sense, because we can't really graph very well in 3D. It's not going to make sense. So I really want you to understand what's going on here in two-dimensional space, in that if you have intersecting lines, if they intersect in one point, there's only three options. They're going to intersect in one point, they're never going to intersect, or they're going to be the exact same line. And we'll investigate the other two options here in a second. But I do want you to get, if you have intersecting lines, that means you have exactly one solution. So like this other one that we investigated, -4, 3, -4, 3, it was right here. So -4, 3 was a solution of the first one, but it didn't hit the second line. They don't intersect at that point, so it met the first requirement, but not the second one. So that's where we're coming from there.